Today in our presentation, we will go into deeper into the what are the standard AFR solutions or AFR equipments we are providing to cement industry. What is the alternate fuel value chain? Various alternate fuel firing products. In that, we will go into deeper into our standard product like low NOx inline calciner, jet flux burner, chloride bypass system, alternate fuel drying system, hard disk, and improved version of hard disk, that is hard disk. Yes, if you see, alternate fuel have many synergies with cement manufacture. So FLSmith technology with the combined support from CII, we provide end-to-end solution to cement plants to enhance their TSR percentage. Some of the broad support where FLS supports our customers are pyrotechnology, alternate fuel handling and supporting technology, hard disk for tires and fuel flexibility, ECS, process expert for optimal fuel control, multi-fuel control system, emission monitoring and reporting system, which is a very key to the cleaner. What is the value chain in the alternate fuel utilization in cement plants? So although we provide a complete solution, it is not always necessary to implement major modification in order to increase the TSR percentage. Test the alternate fuel within less than 5%. You need not have a major modification in your existing equipments. If at all, if you want to go for a higher TSR percentage, more than 5%, taking to a level of 50 to 60 total TSR percentage utilization, then we have to look deeper into various aspects, starting from receiving of various type of alternate fuel, segregating, feeding system, firing equipment, what is the impact on process, what is the impact on quality, what will be the emission coming out of the cement plant. Those things has to be analyzed upfront before going into the system. Of course, we have to work the TOC also, total cost of ownership, for the investment we are going to make. So as such, and to help your cost at a minimum, we also offer a special upgrade alternate fuel audit combined with the CII to focus on key components including major mapping of alternate fuel in and around your plant, ensure uninterrupted supply of alternate fuel in correct quality and quantity, layout feasibility study, how to upgrade your existing equipment, process quality impact and emission support. So in this roadmap, you can see the first part in left side of this presentation. You could see the support, like who are the waste generators in and around your plant, and how it is collected, how it is segregated quality wise, quantity wise, and it is transported to your plant. So this kind of support CII is rendering. We have joined hand with the CII. With the support of CII, we cement plant are getting the benefit of end-to-end solution to enhance the TSR percentage. In the second portion, in the right hand side, you could see what are the various type of equipments presently available, the latest equipment to enhance the TSR percentage in cement plant, how to retrofit with your existing equipment, or if you are trying for a new installation or a green plant, you can go with the latest technology with a digitalization. So the basic overview and concept, standard concept available in AFR system is that receiving of alternate fuel, how it is transported, how it is stored and extracted, and feeding and firing equipment. So there are various steps involved in this material handling, that is alternate fuel handling system, and various type of equipments are available. So which can suit and select based on the layout feasibility. We can combinedly come to your plant, we and FLS as a team come to your plant, study the layout, and then we have to design what is the correct equipment feeding system needed for your plant to suit the available alternate fuel in and around your plant. So what is the basic approach we follow in enhancing the TSR percentage or providing a solution to fire AFR in your plant is that first we will collect the what are the AF properties and the type of alternate fuel available in and around your plant, what is the required quantity required based on the TSR percentage needed in your plant, based on the capacity of your plant. We will work it out, the cost economics. Then what is the pre-treatment or screening needed inside your plant or outside your plant, those requirements will be evaluated. What is the storage capacity and the storage method needed for the alternate fuel? Extraction and mixing requirement will be evaluated. What are the dosing equipment conveying method that will be decided based on the existing layout, if it is going to be a retrofit or upgrade of your existing system. And what is the feed method, whether it is a mechanical or pneumatic method, what is the limitations in your pyro system, and a feed point identification. So these are the broad activities we do or support you while you think to enhance the TSR percentage. And also, in addition to this, we also provide you the what are the safeties has to be followed during AFR firing, risk and environmental aspect to be considered while selecting the equipment in terms of de-dusting or fire detection, firefighting, and the order reduction. So this kind of support we are providing to all our cement customers. So when we see the overall products, we can classify that into four broad classification. That is reception, transport, storage, and feeding. And under reception, some of the equipments we offer are surface feeder, docking station, volumetric dosing equipment, apron feeders, screw bottom conveyors. In transport, we have various equipments. Those are screw conveyors, drag chain conveyors, submerged scrap chain conveyors, chain scrappers, pipe conveyors. So in storage and feeding equipment, are FeedX overhead reclaimer, silo and bunker activator, and screw bottom storage system. In feeding, it is a bulk fuel spreader. It's available. And then firing equipments we will see in the next slide. So while going into our firing equipment, we have two types of firing equipment. One is the low NOx calciner itself, and the second one is our hard disk reactor. So in the advantage of this low NOx calciner is that it has gives a combined advantage of utilizing alternate fuel for earlier fossil fuels and also generating less NOx emission. So our low NOx calciner is well suited to substitute 80 to 100% of calciner firing. So the overall TSR percentage can be achieved 50 to 60% in using alternate fuel only in low NOx calciner itself. So this low NOx calciner can take alternate fuel of size 100 by 100 millimeter. That is a two-dimensional material can be easily fired in the low NOx calciner if the calciner is rightly sized with required residence time. Tire chips up to 50 mm can be fired in our low NOx calciner, that it can be fed into the Kiln riser or the exact location where the alternate fuel has to be fed, that will be evaluated during the baseline study. So large particle stays in the bottom zone of the calciner. We can see in the bottom zone, in the riser zone, where we get ample time for drying, ignition, and complete combustion of alternate fuel. So high oxygen level that ensure faster burnout means in TAD we get 21% oxygen. So with a high temperature, we enable to complete combustion of alternate fuel. So the long residence time and low velocities are ideal for alternate fuel firing, so which is achieved in the low NOx calciner. Once the alternate fuel is fed at various locations, you can see at 4 different locations we are feeding the alternate fuel based on the alternate fuel physical characteristics. So once the alternate fuel is fed into the calciner, the particle falls, sinks back, and it gets combusted, and it is pulled upwards through the gas velocity. So normally the calciners are designed for 6 to 7 residence time with a gas velocity of 8 to 10 meter per second in the cylinder portion, which ensures full burn out of any type of alternate fuel or any type of RDF. So during a greenfield design, we also size the calciner for a higher residence time, that is up to 15 seconds residence time, including the gooseneck, that is up to bottom stage inlet. For 15 seconds, we design specifically to utilize a higher TSR percentage of alternate fuel. So in this slide, we show you the different location identification for feeding the alternate fuel in the low NOx calciner based on the physical characteristics of the alternate fuel, like the size and bulk density. Based on these two characteristics, we decide where the alternate fuel has to be fed into the pyro process, so that there will be a very minimum process interference or any quality fluctuation. So there are 9 types of different alternate fuels. In this table, we have given what is the particle size and what are the typical sources of this alternate fuel. And in the right hand picture, we have given the serial number, that is a category, and a feeding location. So we can fire alternate fuel, or we can size alternate fuel equipment to fire 100% substitution of alternate fuel, that is 40% in main burner and 60% in calciner. So overall 100% substitution of alternate fuel is possible in a cement plant, provided you get an uninterrupted supply of quantity of alternate fuel in right quality. And you upfront, we have evaluated the requirement of drying system of alternate fuel, any chloride bypass system is needed, or what will be the impact on the quality, emission, and process has to be pre-assessed. And if properly designed plant, you can go ahead, easily go ahead with 100% substitution of alternate fuel. So in this slide, we are comparing two different types of calciner system. In the left hand side, we are showing the traditional or old Lonax calciner system, where the residence time and the riser residence time. Basically, the riser residence time will be 0.15 to 0.2 seconds, which is a old traditional Lonax calciner, which will yield around 800 to 900 milligram normal meter cube at 10% O2 level NOx emission, the main stack. Then we have come up with latest generation or improved design version of Lonax calciner, where reduction zone residence time has been enhanced from 0.15 seconds to 0.8 to 1 second. So which enables to further reduce the NOx emission when you are firing like petcoke, 100% petcoke, or if you are combinedly firing alternate fuel along with petcoke, then you need higher reduction zone residence time that is achieved in the right hand side, that is improved Lonax calciner system. In this type of calciner system, we are achieving less than 600 milligram normal meter cube at a 10% O2 level NOx emission while firing 100% petcoke, which is having a nitrogen content of less than 1.4% nitrogen. So this type of calciner is well suited for upgrade projects. We can retrofit in your existing Lonax calciner. Based on the layout feasibility, it can be retrofitted with this improved version of Lonax calciner, which is very well suited for firing alternate fuels. So here we showcase one case example where the plant wants to increase the alternate fuel substitution, so that we have done some modification in the calciner along with some preheater cyclone modification, so that the plant can increase the alternate fuel substitution rate more than 10%. So in this plant, after modification, what we have done is that the inline calciner outlet gooseneck has been enlarged to the bottom cyclone inlet, so that we get additional residence time to ensure 100% complete combustion of alternate fuel. So after the retrofit, the plant capacity has increased from 5740 TPD to 6300 TPD. The fuel consumption around 64 kilocalorie has reduced. That is because change in cyclone, and also top stage cyclone was replaced with the latest generation CCX type counter current exchange cyclone. And because of bigger cyclone retrofitted, the pressure drop across the preheater also has come down. NOx emission has reduced due to the increased reduction zone, and also CO has come down due to increased residence time, and the plant is now very well suited for increasing the alternate fuel substitution. So what we have done in this plant is that replaced all the cyclones with a bigger diameter. Top stage cyclone is replaced with CCX cyclone, that is counter current heat exchange cyclone. Lonax calciner is upgraded for 6 seconds residence time. New TAD, bigger TAD, and routing has been changed, and a new Kiln riser and a smoke chamber. In this case example 2, the plant wants to increase the alternate fuel substitution, that is with the addition of a hard disk reactor itself, a hard disk 8 dia hard disk was retrofitted in this plant along with the pyro preheater upgrade and raw meal upgrade, then the plant can able to increase the thermal substitution rate up to 90%. 90% thermal substitution rate was increased with the new hard disk as well as change in the burner, new burner. With along with the increase in pyro capacity, that is from 3700 TPD, the capacity also increased to 5000 TPD with high AF substitution, so that the payback can be easily achieved less than 2 years. So what are the process implication or process constraints optimization needed when we aim higher TSR percentage in your plant is being detailed in this slide. That is, loss of production capacity due to the capacity of the ID fan will come down whenever we are using alternate fuel, mainly due to the low calorific value of the alternate fuel combined with high moisture content eating away the ID fan power, means ID fan capacity or increased ID fan power. This is a main constraint whenever the plant needs to go for an higher TSR percentage. And other components which come along with the alternate fuel are like chlorides and sulfides, sulfur, which gives process fluctuation or process hindrance while firing the alternate fuel. And fluctuation or reduced clinker quality, any impact on the clinker quality is always foreseen whenever higher percentage of TSR is tried in any plant. CO and HCl emissions has to be mitigated. So with the process know-how and choosing of a right solution, right equipment, the challenges, these above said challenges can be easily addressed and reduced significantly for higher TSR percentage. When we see the when we are talking about the ID fan capacity is being reduced when alternate fuel is percentage is increased, that is mainly because alternate fuels coming with high inherent high moisture, feed moisture, and the low calorific value. These two combinedly, it's eating away the margin available in the ID fan. If a margin is not available, then there will be a penalty in the output. So in this slide, we are comparing the two different fuel. That is, one is anthracite fuel or a petcoke type of fuel with RDF. So we can see that the increase when the moisture content is increasing, the increase in the flue gas amount is more or less a flat when we are using petcoke, or slightly it is increasing. Smooth increase is there. When we are switching to RDF firing, with the increase in the moisture content, the increase in flue gas amount is tremendously increasing. So there is a steep increase in the flue gas amount when we are switching from one fuel, that is a coal or anthracite, to RDF. So if you see, will be a 15% reduction or increase in power or fan capacity will be foreseen when just a 5% increase in volume of the flue gas. So that has to be studied in detail upfront before the plant wants to increase the alternate fuel. So in this slide, two comparison has been given for alternate fuel substitution rate with what will be the impact on the fuel and preheater fan power consumption. So for every 1% increase in alternate fuel, roughly we can arrive at thumb rule of 5 kilocalorie increase in fuel consumption is expected. So we have to look into the other possibilities along with the alternate fuel. What are the various possibilities available to reduce the fuel consumption or to maintain what is the existing fuel consumption the plant is operating with the increased TSR? So that should be the aim. So that we take care during our baseline study. So this is another case example in one of the plant when they tried to start alternate fuel and they want to increase the alternate fuel TSR percentage. What is the impact on fuel and power consumption? This is one of the plant in Egypt where in the existing plant which is operating at 5650 tons per day, they are operating at 734 kilocalorie per kg clinker fuel consumption and 6.97 kilowatt hour per ton as the preheater fan power consumption. So when they increased the TSR percentage to 7% TSR, they installed a hard disk reactor of 6.3 size. Then they could be able to go to 7% TSR substitution, but the fuel consumption has increased to 757 kilocalorie per kg clinker from 734. and power consumption also increased by 1.7 units. When they want to increase further the TSR percentage from 7 to 14%, additionally calciner has to be increased to have a additional residence time. Then they could be able to achieve 14% TSR, but the fuel consumption further increased by 1 unit, around 1 unit, and the fuel consumption also gone up to 766. From the baseline value, if we see around 30 to 32 kilocalorie fuel consumption has increased for 14% increase in TSR. These are some of the products which we offer for alternate fuel usage is the jet flux burner, which is a modern burner which can be used for any type of alternate fuel and 100% substitution in the thermal firing. And the chloride bypass system, this we are designing based on the type of alternate fuel, and we analyze your chloride content, and the chloride bypass will be needed if the hot meal chloride percentage is crossing 0.8. 0.8 is the limit. 0.8 to 1% is the limit of a chloride content in your hot meal. If it is crossing, then we have to retrofit your system with the chloride bypass. Chloride bypass can be easily retrofitted in the existing system after the layout study. So these are some of the drying equipments we are offering based on your layout and investment requirement. We have 3 different type of drying systems. One is a drum dryer, belt dryer system, and a flash dryer for alternate fuel drying. And then we also offer you a process expert system for multi-fuel control. It's an automatic PXP system which controls your alternate fuel and fossil fuel in combination and provides you good control without increase in your TSR percentage. So this is some of the layout for a hard disk location. This slide I will explain you. The alternate fuel in hard disk, it can take a feet size of 1.2 meter, which are all bulk coarse RDF MSW wood chips in combination. Also whole tire 1.2 into 500 mm size can be easily fired in the hard disk without shredding. So when you are using hard disk, different multi-fuel alternate fuel without shredding can be easily utilized in the hard disk. 100% thermal substitution in the calciner firing is possible with hard disk utilization. This is the layout for hard disk. Some of the equipments come along with when you are retrofitting for alternate fuel usage, or some triple gate, multi-dividing gate, and diverter gate. Based on your layout, we will suggest. This is one example where the NOx emission as well as the CO percentage has reduced while using TSR percentage. This is a hot list, reference list for hard disk. Around more than 60 hard disks has been sold out. For an SLC type of calciner, we cannot retrofit the standard hard disk. So for that, we have come up with an improved version that is called as a hard disk S, specifically for SLC type of separate line calciner system. This hard disk S can be easily placed in the ground itself, and also the whatever the ash generated can be taken out from this hard disk, and it can be stored or thrown away. So that is the main advantage of this hard disk S.